Hi, I'm going to be your instructor today, and we're going to talk about fractions, decimals, and percents. A lot of people get confused about these, and the thing about them, they're all the same thing. I want to convince you of that, give you a little bit of insight into how to do conversions, and show you a few connections. The best way to watch this video is to get out some paper and a pencil, and every once in a while I'm going to pause and ask you to write down or summarize or try a few problems on your own. So let's get started. Most of us are familiar with fractions. These are some fractions with a numerator of 1, that's the number in the top, and I have a lot of various denominators. What I usually do with this particular lesson is that I ask the students in the audience for a particular fraction. I have them pick a fraction, any fraction. And most students tend to pick fourths and eighths, things they're familiar with. I'll choose a few just at random. This is not scripted, so you can kind of imagine that I'm just picking something at random. Suppose I pick 25ths, and this is the demo I do. If someone tells me, for example, 7/25ths, I can convert it to 0.28 or 28%. Nothing amazing about it, and in fact, by the time you're done, you're going to be able to do any of these fractions instantly, immediately in your head. Suppose someone picked 50ths, and they told me 13/50ths. I know that that's 0.26 or 26%. By the way, we don't read this 0.26, we read it 26 hundredths. This is 28 hundredths, and I use that fact to make this a little bit easier. Suppose someone had picked, I don't know, 9/8. This is an improper fraction, which is 1.125, which is 112.5%. Again, you're going to be able to, at the end of this video, and with about 2 hours of practice, and if you follow the instructions I give you, you will be able to do any of these fractions with any numerator, provided it's not too large. For example, 1,759 25ths, you're going to have a little bit more trouble with than, say, 57 25ths, which is 2.14 or 214%. So let's get started. I'm going to start with something you're very familiar with, and I'm going to make a connection, or help you to make a connection. I can't make it for you, but I want you to think of what you've always called these. They have several names. Fourths, obviously, since there's a 4 in the denominator. But another way that we describe them is as quarters. So if I said to myself, oh, I want to know what 3/4 is, instead of thinking of it as 3/4, I think of it as 3/4. 3/4 is 75 cents. And that happens to be 75 cents. Did you know this particular symbol is a shortened version of this particular symbol? And this particular symbol is a shortened version of this symbol. This happens to be 75 hundredths. If we read it as if we read the decimal properly, we read it as 75 hundredths. This is also 75 hundredths. This is 75 hundredths. This is 75 hundredths. All of these three symbols are mathematically equivalent. You can interchange them. So if I said 5/4, some people need more time than others. All I want you to do is visualize in your hand 5/4. And maybe pause the tape, or rather pause the video that you're watching, and grab a piece of paper, write down the answer before I say it. Timing is everything in learning mathematics and learning anything, and you need to work ahead if at all possible. Anyway, I've got 5/4, which happens to be $1.25, 125 cents, or 125%, 125 hundredths, yada, yada, yada. So, 7 quarters. Think about how much you have. Visualize them in your hand. You're probably going to put a stack of 4 and another stack of 3, and you're going to have, hopefully, you got it, $1.75, 175%. Or 175 cents. It means the same thing. Now what you're probably thinking is, the hell can't be this easy because somebody would have told me. I am. And yes, they are all more or less this easy. There is a little bit of memorization you're going to have to do with a couple of them. You're going to have to do a little practice, and you're going to have to do a little bit of teaching. Let's look at these. These are tenths, of course, but we can think of them as money as well. Think of what a tenth of a dollar is. We call this quarters or fourths. We call these tenths or dimes. So when I see tenths as a fraction, I just simply ask myself how many dimes it is, what they're worth, write it out. Suppose I have 7 dimes. Most people are aware that they have 70 cents. Now this 0 is not necessary. We can put it or not. It's completely optional. But if I write it like this, when we read this decimal properly, we don't read it as 0.7, we read it as 7 tenths because the 7 is in the tenths place. Just like we could read this as 70 hundredths. And another word for hundredths is percent, or cent for short. All of these are mathematically equivalent. And if I said, for example, 13 dimes, write down an answer, if you dare, $1.30, or 130%. Fairly easy problems. Probably the most familiar. One that you may or may not be familiar with, probably not though, is the 20ths. And I'm going to ask you to make another connection with something you knew before. You happen to know that there are 4 quarters in a dollar, 10 dimes in a dollar, and 20 what in a dollar? Well, 20ths are literally nickels. They're worth 5 cents each. I like to think of this as having a value of 10 cents. This has a value of 25 cents. This one has a value of 5 cents. There are 20 nickels in a dollar, so I can think of them as nickels. All I have to do 7 20ths is simply ask myself the question, how much is 7 nickels? And if we figure it out, we have 7 nickels, that's 5, 10, 15, 20, 25, 30, 35 cents. Which happens to be 35 cents, or 35%. Like I said before, these are extremely easy if you make proper connections with what you knew before, and Americans tend to be really good with money, so we can do money. How about 13 20ths? A little tougher. The 10 nickels makes 50 cents, and then I've got 3 extras. 3 more nickels after 50 cents is 65 cents. We can write it like this. We can write it like this, which happens to be 65%. How about if I said 23 nickels? We can think of this as a mixed number. If you must, you can convert it to a mixed number. I don't usually like to do that, but it's certainly not wrong to think of this as 1 3 20ths. But for me, 20 nickels makes $1, and I've got 3 extras. That makes $1.15, which is 115 cents, or 115%. How can you have more than 100%? by having more than one whole thing. A percentage is a small portion of a whole. And when you go over 100%, you're simply asking more than one thing. This happens to be $1.15 more cents, or 115%. One last one, 19/20ths. And we can kind of think in reverse on this one. I'm how much short of $1? How many more nickels do I need to make a whole? And I need one more to make $1. So I'm 1 nickel short of $1, or I have 95 cents, which is 95%. Or 95 cents, if you like. Now, again, you're probably thinking, well, now you've run out of money, so how are we possibly going to be able to do these like you promised? Well, we haven't actually. We have hundredths left. And you probably have guessed already that hundredths are 1 cent each, or 1 cent. And, of course, if I write 57 hundredths, I just mean 57 hundredths. Notice, this is 57 hundredths when read properly. And this is 57%. This symbol was originally written, literally, as per hundred. Here we go. 57 per hundred. You've heard of miles per hour. This is 57 per cent. Cent is 100. And of course, if I can go over 100, I can do less than 100, I can do 13%. And I'm all done. That's all of my money. But here's what I can do. Because I can think in terms of money, even though I don't have 2-cent pieces anymore, I can still think of these as being worth 2 cents. You were probably wondering how I did the 50ths. Well, it's very, very simple. I simply give them a value of 2 cents. And I can do 50ths. If I say 13 50ths, I literally mean 26 cents, because each 50th is worth 2 cents. That's 26%. Another way of looking at the same thing, and the way you may have originally seen this, is that when we write 13 50ths, in order to convert to a decimal or a fraction or a percent, or decimal or a percent, we would like to have it over 100. And when we look at equivalent fractions, all we have to do is multiply by a common factor in the numerator and the denominator to get where we want to go. I would like to turn 50 into hundredths, so I have to multiply by 2. The problem is, if I multiply by 2 in the denominator, I've changed the value of the fraction. But if I also multiply the numerator by 2, the overall result is multiplying by 2 divided by 2, which happens to be exactly equal to 1. That's why you're allowed to multiply in the numerator and the denominator by the same value, and you have an equal fraction. This is 26 hundredths. Guess how we read that? 26 hundredths. So basically, what I'm asking you to do every single time is to change the denominator to hundredths by multiplying by the appropriate factor. In this case, we must multiply 4 by 25 to make 100. So each numerator is worth 25 cents, if you like. To change tenths, I have to multiply 10 times 10 to get 100. 20ths, I have to multiply 20 times 5 to get 100. 50ths, I have to multiply by 2 to get 100. And hundredths, I have to multiply by 1 to get 100. Using all I just said, I would like you to think in your own terms of how you can go further with this knowledge. This is called extrapolation. It's a formal process in mathematics where you take some information that you know and you extend that information to the outside, to something you don't know. So what I'd like you to do is think in these terms, how I got the numbers I got, where I got my number value, and I'd like you to come up with your own rule for changing 25ths. You also, if possible, I would like you to come up with your own rule for changing fifths and for changing halves. They all have a number that you need to multiply to get 100, and they can all be given a value in cents, if you like, to change them to decimals, percents, and fractions. I don't want to go over 10 minutes, so what I'm going to do is I'm going to call this part 1, and in part 2, I'm going to go back and revisit those particular 3. Hopefully you can try them on your own. That way you don't even have to pause the video. And I'll be right back, and we'll look at those 3 and the others. So good luck with that. Give it a try.